The half-life of a radioactive source will determine its activity and how long it will be unstable. So remember that half-life is the time it takes for half of radioactive nuclei in a sample to decay. Here we have two isotopes which contaminated the environment following the Chernobyl and Fukushima disasters, iodine-131 and also cesium-137. Iodine-131 has a relatively short half-life of just 8 days, whereas cesium-137 has a very long half-life of 30 years. But you don't need to remember the half-lives of these or any other specific isotopes for your exams. But the half-life affects the nature of the hazard it presents. So how are these hazards different? Well, sources with short half-lives will have high activities, meaning they can give high doses of radiation in a short time. So we get a high dose in a short amount of time as there are many decays happening. These sources will become safe after a short amount of time. So in general, we say a radioactive source is safe after 99% of its atoms have decayed, and this will be after 7 half-lives. Iodine, for example, will be safe quickly, as 7 half-lives is only 2 months. For your exams, you don't need to be able to recall at what point mathematically a radioactive source is generally considered safe, but you should be able to give a general description of how this links to half-lives. So how is the hazard from isotopes with long half-lives different? Well, sources with long half-lives will have low activities, meaning they only give low doses in a short amount of time. So in a short amount of time, the dose is less than from an isotope with a short half-life, as there are fewer decays per second, so the dose is spread out over time. These sources will contaminate their surroundings for a long time, as it takes a while for them to become stable. In the case of cesium, it's unstable for over 100 years. So it gives out radiation for a long time, so we receive a long, consistent dose. In your exams, you may be asked to compare the risks of different radiation sources given their half-lives.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!